So now let us see on how we can be able to analyze this case of the projectile motion, and that is top angle ground case. So what is this kind of the projectile motion? Now recently we have talked about the ground back to ground case, and that I'd like you to watch that one before this lesson, because whatever we're going to talk about here will be something and applicable to actually those cases of the projectile motion. So this is the nature of the ground back to ground case of the projectile motion, and where the object has been raised from the ground level and back to the same ground level after some time. And we have also talked about the top horizontally released ground case of the projectile motion. Now this is where the object is released from the top of the building and to the ground level, but horizontal in this case. So now up to this far, these are the two cases of the projectile motion that we have recently talked about. So in this video, you can have to discuss about the top angle ground case, where the object has been raised from the top of the building but at an angle with respect to the horizontal, and then actually land on the ground. So that's the case we are to discuss about in this video. So let's say this is can be a height of the building, or whichever the height we may think about, but we should have it, which to be in this case. Let's say this is the ground level. Say this is the ground level, and we have the 2D coordinate system, somewhere here, and we should have it in this case. Of course, now let's say the object has been raised, from the top at an angle and up to this point. Let's say this is the case. Now, assuming that the angle in which the object has been raised, and with respect to the horizontal, which is x-axis, and of course this is why this is the x-axis, and let's say the angle in which the object has been raised with respect to the horizontal, let's say it is given as the angle theta, and say the object has been raised with initial velocity, let's say given as, let's say v. So how should we be able to analyze some sort of aspects the way we discussed about the other cases of the projectile motion, like the distance traveled, the landing speed, and some sort of, in other words, we should have to analyze this case of the projectile motion in actually these axes actually separately. No principle remains the same. Now, whichever the case of the projectile motion, analysis has to be independently done. So let's start with the analysis along x-axis. So now the object has been launched from this position, at an angle theta with respect to the horizontal, and the launch actually velocity or the speed is given as v. Now, what is the initial velocity along x, which is given as vix? So now the initial velocity will be obtained upon resolving this vector into components. Upon resolving this velocity into components. So which means we'll have it as v cos theta. So that's the initial velocity along x-axis. And our principle remains the same, that along x-axis, acceleration due to the gravity is zero, because along that axis, gravitation force is not felt. So we'll have the zero acceleration due to the gravity in that case. And we understand from the concept of the actual linear kinematics that whenever the object is moving with zero acceleration, it means that particular object is moving at a constant speed. Hence, as the object is going to strike the ground at this point, it will have the actually velocity along y-axis that will be given as v of x. So mind you, this is the typical projectile motion where the object is going to strike the ground in a two actually dimensions. I will have the x component and also the y component as well. So as the object is going to strike the ground, this will be the component along x that represents as the final velocity along x as the object is going to strike the ground. And of which, since the object is moving at a constant speed, it means final velocity, which is v of x, it is the same as v cos theta. In other words, velocity along x-axis does not change. Therefore, initial velocity along x-axis, which is this, it is the same as the actual final velocity along x-axis in that case. And the reason being that along x-axis, the object is moving at a the object is having the z acceleration, hence it is moving at a constant speed. Now, what is the distance traveled along x-axis from this point up to this point? That's what you call the horizontal distance. So how should we have the horizontal distance along x-axis from this point up to where the object is going to strike the ground? So now the horizontal distance will be given as, and that should be that of v cos theta and the times t, and this t corresponds to the dot term for the whole entire journey. So the time takes for the object to move along, the time takes for the object to move along x-axis from the point in which the object has been raised, to the point where the object is going to strike the ground. That time is said to be the time for the whole entire journey, which is given as the t total. So keep that in mind. So now, which means if we have the horizontal distance and the initial velocity along x-axis, we can be able to have the total time using that formula. So now you can know what is happening there. So that's how we should have to understand about the analysis of the motion along x-axis, and that's for this case of the projectile motion. So there's nothing to do with a sort of a range as we discussed it about in let's say ground back to ground case, because this case of the projectile motion is not symmetric in nature. So we cannot use the formula for the range that we derived in the previous lesson about the ground back to ground case of the projectile motion. Rather, the range or the horizontal distance will only be calculated if we know the initial velocity along x and much as we know the t total. So we'll have that understood. Now let's think of analyzing the motion of the object, in this case of the projectile motion, now that is along y-axis. So you have to understand that along actually y-axis, acceleration due to the gravity is given as negative 9.81 meters per second square. So in other words, acceleration along y-axis, it is given as the acceleration due to the gravity, because as the object is moving along y-axis, always there is an influence due to the gravitational force. Hence, we'll have the acceleration due to the gravity that is being given as 9.81 meters per second square. So now get it in that way. And what is the initial velocity along y-axis? Now, since the object has been arranged at an angle, then I should have to expect that the initial velocity along y-axis will be obtained upon resolving this one into components. Now in this case, we'll have it as VIY. We'll have it as VIY that is being given as V actually sin theta. So that's the initial velocity along y-axis in that way. Now, what is the time takes for the object to move from the point of release to the maximum point? So the time will be obtained like the same way we discussed it about in the case of the ground back to ground case of the projectile motion. Because as you can depict it, what is happening here is this. if we tend to have it in this way, up here the case that we have, it is the ground back to ground case. So which means even the time takes for the object to move from this point up to this point, it will be the same way we discussed about this in a ground back to ground case of the projectile motion. Much as this is the maximum point where the velocity is Vmax. So the time takes, which is the Tmax, and for the object to move from this point up to this point, will also be calculated in the same way. And that much I understand, what it entails. So should it be that you missed that lesson, just have to ensure that you have come across that one, or else I'll have to provide the link in the description actually section below. Just have to check or go through the cases of the projectile motion on the list of my video playlist. You'll be able to come across that case of the projectile motion. So now, how about a distance from the point of release to the maximum point? The issues to do with the distance also be calculated in the same way. In other words, what is the height, or what is the height for the object to move, that is from the point of release to the maximum point. That one also be calculated in the same way, the way we discussed it before. So keep that in mind. And also you should have to understand, let's say the height of the building, it is given as, let's say, h, and let's say the maximum height here has been, let's say, calculated as, let's say, given as a capital H. So now, which means the overall maximum height the object is from the ground will be given as, let's say, h max is equal to h plus this h. So which means, this is the height of the building, and this is the height of the object, from the top level up to the maximum point. So the summation of these two heights gives us the overall height in which the object is, from the ground up to the maximum point. So now you know what is happening there. And I would also love that you should also go through what we discussed about basically in the free form motion. We talked about the different cases in the free form motion that will be very important for you to apply as well, because those cases are very important as well. Much actually, since some of the some of the concept we are talking about here already being expressed in the lesson of the free form motion, where we talked about different cases of the free form motion. We talk of the one-way up motion, where the object is moving upwards only, and one-way down, where the object is moving downwards only. And we talked about the way up and down, where the object should be a ground back to ground case, where the object has been launched up and get back to the same original position. And we also talked about this case of the free form motion, where the object has been released from the top and being up, then back to the ground level. So you should have to try to come across this case of the projectile motion, so you also be able to appreciate. And the concept we're talking about here, it is much related to that one. So that would be beautiful for you as well to go through that one. But just have to know that the overall height in which the object is from the ground level, it is given as the height of the building and the height that the object has to attain at this point. So keep that in mind. And now, what is the velocity of the object, or should it be, what is the final velocity of the object along y-axis as it is going to strike the ground? So now we are looking for VFY, that is the final velocity along y, as the object is going to strike the ground. So now we'll have to calculate the final velocity along y-axis using the acceleration formula. We have VFY is equal to negative GD and plus v sin theta. So this is the formula that I'm going to use to have the final velocity along y-axis. So where this d is the total time, the one that we also used when we are discussing about the horizontal distance, and this is the initial velocity along y-axis. So take note of that. So this is how the final velocity will be calculated in that way. And how about, let's say, the landing speed? We'll have that, and upon having the magnitude of these two components, that is, we are looking for the magnitude, which is actually this one. So have the landing speed that is being given us. Now have actually v f x square. So have v f x square and plus v f y square. So have the magnitude, and the direction of the actually landing will be given as this angle theta. So you'll be able to have that in that way. But of course, this angle won't be the same as this angle, because this case of the projectile motion is not symmetric in nature. So you see that one. And also, you should not have to expect that, you should not have to think that the time takes for the object to move from here to this point, which is the t max. It is not. You should have to understand that for this case of the projectile motion, total time is not equal to 2 times t max. So it's a different thing, because this nature of the projectile motion is not symmetric in nature. So we won't have that. So but now you know how we can be able to analyze this case of the projectile motion in that way. So how can you be able to have the height of the building in case we are not being given? So now this height of the building can be actually calculated using the displacement formula, which is given as AC is equal. Now we should have to call it as, let's say, height given as h is equal to, now have the initial velocity along actually y-axis, and that times the t total. Now the term I'm going to use will be given as the t total minus half g t total square. So which means we can be able to have the maximum, actually we can be able to have the height of this building, using this formula. So where this is t total, like that, and this is the initial velocity along y-axis. Should be that. Or else we can also use this as well. That is, the height is equal, v, that is vfy, that is the final velocity along y-axis, plus the initial velocity along y-axis, which is v sin theta, and the divided by 2 times t total. So we can also have that and up to have the height of the building. So take note of that. Or else we can also have it in the same way, in this way as well. We can also have it using this formula v square, where this is the final velocity. We'll have it as vfy, final velocity along y-axis, will be given as the initial velocity, that is v sin theta, v sin theta to the power 2 and the minus 2gh. So where this is the maximum, this is the height of the building, or we call it as the displacement, it is the same. So keep that in mind. But you observe that the displacement, which is the height of the building, will be given as the negative, because the object is said to move from this point and up to this point, where the displacement will be given as the negative. So keep that in mind. So actually, which means now we can also be able to have the total time using the displacement or the height of the building, in the sense that if we are being given the height of the building, we can be able to have the t total using this formula. So height of the building be equal to, we'll have it as v sin theta and that times t total minus half g t total. where you'll be able to substitute for the height of the building. And basically, since the displacement will be given as the negative, since if the object is to move from the top up to this point, then the displacement, which is the height of the building, will be given as the negative. So which means as you're going to substitute the height of the building here, you're going to substitute that one as the negative number. So in such that you should be able to have the d dot as the positive number, and also from the fact that the displacement is given as the negative there. So take note of that. Likewise, we can also have the d dot using this formula. Height is equal, final velocity, which is vfy plus v sin theta divided by 2 times d dot. We can also use this formula as well to have the d dot if that's the case. So that's how you should have to understand about the analysis of this actually a projectile motion. Thank you.